Okay, in this video we're going to look at partial fractions. This is for CCA A-Level Further Mathematics. So knowledge of A-Level Maths A21 partial fractions is also assumed. So the process of taking a single fraction, bringing it up into the sum or difference of two or more fractions is known as splitting an expression into partial fractions. And the big important thing here, if the degree of the numerator is greater than or equal to the degree of the denominator, you must first divide the numerator by the denominator. Okay, and what's new this year really is if you could have quadratic factors in the denominator. So say you have an expression like this, and we have what's called a non-reducible quadratic factor. So this is a quadratic factor which you cannot reduce anymore. You can't factorize it, that just means. Then you would write this whole thing in terms of partial fractions as you've got your non-reducible quadratic factor here, and on the top line of it is ax plus b. And then the regular linear term is x minus 2, and that's over c. Sorry, c is over x minus 2. Okay, we're going to look at an example here and how we go about doing this. Okay, so it says we have got 5x squared plus 4x plus 4, and it has to be over x plus 2 upon x squared plus 4. It has to be expressed in partial fractions. So your first step is just say let 5x squared plus 4x plus 4 all over x plus 2 upon x squared plus 4 be identically equal to, so it's just a over x plus 2 plus the non-reducible factor then is the x squared plus c, so it's x squared plus 4, so it's bx plus c over x squared plus 4. Then you just multiply across by the denominator, and if you multiply across by the denominator, you're going to get 5x squared plus 4x plus 4 is equal to a times x squared plus 4 plus bx plus c, that must be in a bracket, upon your x plus 2. And then you find your values of a, b, and c whatever way you want. So I'm going to first of all let x equal minus 2. And if I let x equals minus 2, my left hand side becomes, it's going to be 20 minus 8 plus 4. My right hand side is going to be a times, put the minus 2 into this, you're going to have minus 2 squared, which is 4, plus another 4, which is going to be a times 8. And then you're going to have, put minus 2 into that whole bracket will become 0, so it can just disappear, thankfully. So that's what you have. So what you've got basically, you get 20 minus 8 plus 4, which is just going to be 20 minus 8 is going to be 12, plus 4 is going to be 16, is equal to 8a. So a wee bit of working out, your a is equal to 2. Okay, I think for these ones it's probably easiest to equate coefficients. So I'm going to equate the coefficients of x squared first of all. If I equate the coefficients of x squared, on my left hand side I have 5, on my right hand side, so we bracket this here there, on my right hand side I have got a, and it would be plus b, and you already know your a is equal to 2, which tells you then your b is equal to 3. So you've got your a and your b. We'll just go on down and we're going to equate coefficients of just x then. So on my left hand side I've got 4x's, on my right hand side here if I multiply out this bit there's going to be no x terms. And if I multiply out this bit, I'm going to have bx times 2, so 2b. And I'm going to have c times x, so 2b plus c. So that's 4 is equal to 6 plus c. So a wee bit of working out, your c works out to be minus 2. Okay, so you've found your constants. Your last thing then is to write your answer. So your answer then is going to be 5x squared plus 4x plus 4, that's what they had originally as your denominator, all over x plus 2 upon x squared plus 4 is identically equal to 2, that was my a, over x plus 2, and plus my b was 3, so 3x, my c was minus 2, so minus 2, and that was over x squared plus 4, and that's it done. Okay, on the next page it says, note, remember to check that the denominator, and that has been spelled incorrectly, I'll get that sorted, is completely factorized before attempting to put in partial fractions. So we'll go with this. and we'll hide that spelling mistake of mine. So we will say to do this, what we're going to do is make sure we have factorized the bottom line first of all. So I'm just going to look at this x squared minus 3x plus 2. It factorizes a wee bit better to give you x minus 1 upon x minus 2. This one, unfortunately, does not factorize. Okay, so hence we'll just say minus 2 minus 1, minus 2x minus 1 all over, and it now becomes x minus 1, x minus 2 upon x squared minus x plus 3, which is non-reducible. And that's going to be equal to a over x minus 1 plus b over x minus 2 plus cx plus d over x squared minus x plus 3. Okay, it's just messy this, but it's not any more difficult. It's just a bit awkward. So then here we'll say, if we multiply across, you'll have minus 2x minus 1 is equal to a upon, it's going to be x minus 2 upon x squared minus x plus 3 plus b upon x minus 1 upon x squared minus x plus 3 plus brackets cx plus d upon x minus 1 x minus 2. So signs keep disappearing in this thing for some reason. I don't know why. We're just going to say let x equal, and I'm going to let x equal 1. If I let x equal 1, that bracket will become 0, and that bracket will become 0. So I can get rid of my b term and my cx and c and my d term as well. So that's my reasoning. So I'm going to let x equal 1. And on my left-hand side, I'm going to get minus 3. And then on my right-hand side, I'm going to get a times, that's going to be 1 minus 2 is going to be minus 1. And then 1 squared minus 1 plus 3 is going to be 3. So you've got a wee bit of working out. A is equal to 1. I'll put that in a box. Nothing wrong with that. Okay. What I'm going to do next is I'm going to let x equal 2. And what's my reasoning for this? If I let x equal 2, this bracket will go to 0. And this bracket will go to 0, which will allow me to find my b. So I want to do the substitution method as far as possible. It's definitely easier instead of having to do simultaneous equations or whatever you want to have to do. So let x equals 2. On my left-hand side, I'll get minus 5. My right-hand side, I will just be left with b upon, it's going to be 1 for this bracket. We'll put it into this bracket. We'll put 2 into this bracket. I will get 5. So you just get b is equal to minus 1. So I've got my a value and I've got my b value. Okay, what I'm going to do now is I'll go across here and I'll just do equating coefficients now to do the rest of it. If you really don't like the equating coefficients, what you can do is just substitute any value. So 0 is a nice value to put in. It makes life quite easy. And you'll get, say I put 0 in, I'd get minus 1, say I put 0 in, I'd get minus 1 here equals a times minus 2 times 3, b times minus 1 times 3, and d, that'll go to 0, d times minus 1 times minus 2. So it'll get you another equation with 3 unknowns, and you already know your b and your c. So that's a nice way to do it, but I'm just going to do the equating. So I'm going to equate x cubes. On my left-hand side, I have nothing. On my right-hand side, I'll have a, and I also have a b, and I'll have a c term. But we know, remember, that your a is 1, your b is minus 1, and your c, so c is 0. So you've found your c is equal to 0. We'll also equate your x squareds just. So my left-hand side I have no x squareds. On my right-hand side, now this is where it is a wee bit trickier. You're going to have a x times the minus x is minus x, and minus 2 times, minus 2 times the x squared is minus 2. So what do we have there? Sorry, minus x minus, so you're going to have minus, I am started doing this when I'm thinking this is actually a far too hard way to do it. I definitely will just go back So there you can see, you can start something. That was going to be quite tricky to do, especially doing in your head. So I will just actually go back and let x equal 0. So I'll use that as my method. So let x equal 0. So forget about my equating my coefficient of x. That's going to be awkward to do it actually that way. So I'm just going to have minus 1 is equal to, and it's going to be a times minus 2 times 3 plus b times minus 1 times 3, and then plus d times minus 1 times minus 2. So I'm going to have minus 1 equals minus 6a minus 3b plus 2d. And again, we know what your values of a and b are, so that's going to be, minus 1 is equal to minus 6 plus 3 plus 2d. So minus 1, that's going to be minus 1 plus 3 is equal to 2d. A wee bit of working out your d is equal to 1. Okay, so we've got our a, b, and our c. Your final answer is, therefore, you've got minus 2x minus 1 all over, and write it back in the original format, which was x squared minus 3x plus 2 upon x squared minus x plus 3 is going to be identically equal to 1 over x minus 1 minus 1 over x minus 2 plus 1 over x squared minus x plus 3. And that's it done. Okay, you're ready to do the questions, but before we go on to the questions, in the course of these questions you could come across some tricky enough factorization. So it looks like this is non-reducible, x cubed minus 1, but x cubed minus 1 can be factorized as x minus 1 upon x squared plus x plus 1. And likewise, so if you learn one of these, you can get to the rest of them. So if you learn this one, for example, you can get to this one. You've changed the sign of this. So the second term, the sign's changed. Second term, the sign's changed. The second term, the sign is changed. Likewise, if you learn this one, x cubed minus x cubed minus y cubed is equal to x minus y upon x squared plus xy plus y squared. And again, if you change, this is the sign of the second one has changed, the sign of the second one has changed, and in this bracket, the sign of the second one has changed. So there, you can see how you can learn those fairly quickly by just really learning the first one, and the third one really would do the job.